Okay, what we're going to be talking about today is what's called percent composition. So this is where we're going to be using the molar mass and the atomic mass and those tools that we've been using the last couple of weeks in order to kind of figure out in any given chemical formula what percentage of that is this element or that element or whatever. So kind of a broad example, something you guys might have heard before, is that the human body is made up of 70% water, right? That's a fact that gets thrown around all over the place, and it's correct, right? That's a true statement. But you can break it down even further and look at the individual elements, and it might tell a little bit different story. So water itself is mostly oxygen, if we're talking about like by weight, right? Because it's H2O, it's two hydrogens and one oxygen, but those H's are super tiny. The oxygen is a much larger atom. So by weight, that 70% water, well, that means that about 65% of your body is actually oxygen, right? A lot of your other parts of your body have a bunch of carbons in them. So like all of the fats and proteins and all that, they're all based off of chains of carbons. So about 18% of your body is carbon. Hydrogen makes up about 10%, nitrogen another 3%, and then a bunch of other smaller percentages of other elements like the iron in your blood, potassium and calcium that help your muscles work, that kind of stuff is the remainder. So you can kind of see there breaking down, element by element what a person is made of. You can do the same thing for like the Earth's crust. That's what this example is. So the layer of rock that goes all around the Earth, what we live on top of, basically, it's about 50% oxygen, 47%. There's a lot of silicon in there, a little bit of aluminum, some iron, and then a whole bunch of other trace elements as well. So they're breaking it down element by element and telling you this is how much of each element there is in the Earth's crust or in the human body. Okay, and we're going to be doing kind of that same thing, the same idea, except we're doing it for individual molecules or formulas, chemical compounds. So the way we're going to do that is basically a 3-step process. And the first 2 steps are things that you guys have done 100 times by now if you've been doing all your homework, right? All it is, these first 2 steps, is basically the process we've been using to find the molar mass of different formulas. So your first step is going to be finding the atomic mass of each element, right? And multiplying it by how many of the element there are. Nothing new there. And the second step is adding all of those together to find your total molar mass. So again, nothing new. It should be, second nature to you guys at this point. The third step is where these problems, get a little bit different, kind of go off the rails from the other ones. Because in the third step, you're going to be finding percent composition by dividing the mass of the individual elements. So the number you found in step 1, you're going to divide that by the total mass of the formula. And then that'll give you a decimal, and you'll multiply that by 100 to get to your percent composition. All right, and if that doesn't make a lot of sense, I'm going to kind of show it to you coming up right here as an example, and hopefully this will kind of clear things up. So like we said, the first step, exactly what you guys have been doing for the last 3 or 4 weeks, right? You look on the periodic table to find the atomic mass of each of these elements. So sodium, it would weigh 23, carbon is 12, oxygen is 16. And then you multiply each of them by however many there are in the formula. So if it's Na2, we would have 2 sodiums, so we multiply that by 2. C doesn't have a subscript, so there's just one of it. And then oxygen has a 3, so we multiply that by 3. All right, so we do those multiplications and get these numbers here. Then step 2, we just add them all together. So 46 plus 12 plus 48 comes out as a total of 106 grams per mole. So that should all be pretty familiar. This last step is where it gets a little different. You're going to take the number from step 1 for sodium. So for Na, we ended up with 46. And then we're going to divide that by the total molar mass. So 46 divided by 106. And when you plug that in, here, I'll show y'all. Okay. Sorry. When you plug that in, 46 divided by 106, it's going to spit out this decimal for you. Okay? Your last step here is to take this and multiply it by 100. And that will give you your percentage of sodium in sodium carbonate. So 43.396, we're rounding to 2 decimals in the percentages, so we would say 0.4340. All right. You do the same thing here for the carbon. So you'll take the number we got up here in step 1 for carbon, which was 12, divided by our total molar mass. So 12 divided by 106, and then times 100. That comes out as 11.32%. That's what we've got here. Same thing for the oxygen. You'll take the number from step 1, 48, divided by 106, which was our total molar mass, and then times 100. So it comes out as 45.28%. All right. So if you're ever doing these problems and you get to the end and you want to check and make sure you've done it right, easiest way to check, you take all your answers and you add them together. So 43.40 plus 11.32 plus 45.28, and they should add up to 100. And if they do, that means you're doing good, right? 100%, the whole thing, you're in the clear. If you end up with 100.1 or 99.9 or like somewhere close to that, then don't stress about it. It's probably just a rounding error. But if you're off by more than like 2 or 3%, that means you probably need to go back and check your math. Okay, so well, that's what it looks like if they ask you for the percent composition of each element. So that's why we went through and did it for all 3 of these elements. Sometimes the question won't ask you for each one. It'll ask you for just one specific element. So like this example here, what is the percent composition of oxygen in water? So for that one, we still have to find both of them because we need to know the total molar mass. But when we get to step 3, we're only worried about the oxygen. So step 1 and 2, same as they always are. You're going to find the mass of hydrogen, which is 1, multiply it by 2 because we have 2 hydrogens in our formula. So it's a total of 2. And then 16 times 1, because we only have the 1 oxygen, is 16. Add them together, you get the total molar mass of 18 grams per mole. And then because it's only asking for the percent composition of oxygen, all we have to worry about is that one element. So for that, we would say 16 divided by 18 and then multiply by 100 comes out as 88.888, bunch of 8s. All right, so we round that to 88.89%. All right, this second one on this page, what percent of sulfuric acid is hydrogen? So again, steps 1 and 2, always going to be the same idea, right? We're finding the atomic mass of each element, multiplying it by how many there are, and then adding them all together to find our molar mass. So hydrogens weigh 1, we've got 2 of them, so that's a total of 2. Sulfurs weigh 32, there's only 1 sulfur in there, so that's a total of 32. Then oxygens weigh 16, and there are 4 oxygens, so that's a total of 64. You add all those together to get 98 grams per mole. And then your last step, because the question is asking about hydrogen, you're going to take this mass of hydrogen, 2, divided by the total molar mass. So 2 divided by 98, and then multiply that by 100. So that's 2.04%. Right? So overall, not too bad. Okay. There's one more thing we can do with it though, which is using percent composition to find actual physical mass of an element. All right. So you might see a question that looks like this, where it says, what is the mass of sodium in a 280 gram sample of sodium carbonate? All right. So there's 2 ways you can do this problem. The first one is to go through the process we were just doing, go all the way through it, find the atomic mass of each one, multiply them by however many there are, add them together, get the molar mass. All this same process, steps 1 through 3 here, nothing changes. Find the percentage of whatever it's asking you about. So in this case, it's asking you about sodium. So we're going to take our mass for sodium here, the 46, divided by 106. And that comes out as 0.4340, or 43.4%. All right. And the trick on this one is that your last step is you're going to multiply this decimal form right here, before you multiplied it by 100, by the mass of the entire sample, and that will tell you how much of the sample is sodium. Okay, so you would take this 0.4340 that we just found times the 280, because that's how much our sample weighed right here, and that would tell you how much of the sample is sodium by mass, right? So that's one way to do it. The other way takes a bit of a shortcut, but it's just a different process. You can do it either way. It doesn't matter. It's just whichever one you're most comfortable with, whichever one you think is easiest, right? So again, these first 2 steps, nothing changes. We still need to know how much the sodium weighs, and we still need to know how much the entire molecule weighs. The only thing different here is that instead of dividing the 2 to find the decimal and multiplying, we're going to set up a proportion or a ratio. So what you'll do is put the mass of your sodium, the molar mass of it, over the molar mass of the entire compound. So 46 over 106. And then on the other side, you're going to put an X above the mass of the sample, right? So the mass of the sample is still 280 from this question here. All right, and once you've got this set up, you just cross multiply and solve for X, right? This is something you should have done in algebra. We've done it a little bit earlier in the year, so you should be at least somewhat familiar with cross multiplying like this. And if you're not, you can always just use the percent method. So for this, if we're going to cross multiply, we would go 46 times 280. And that comes out as 12,880. We also have 106 times x is what it would be equal to. And then to get x by itself, we would have to divide by 106. And our answer here would be 121.51. So the answers are different by 0.01, which is just, it's a rounding error, right? They're pretty much the same answer, which is what you want. So either one of these methods works. Just pick whichever one you think is easiest. All right. So those are all you're going to see today is these couple, I think, 3 different types of problems. Let me know if you have any questions. I'll help you out.